Hello everyone, welcome back to the channel. Thanks so much for joining. So today we're going to talk about 4 things that are essential for mastering VBA. I wish I would have had a video like this when I first started coding because it makes things much easier to understand what exactly is going on. Now these 4 concepts, again, are essential. 2 of them are a little bit tricky, and so you need to know how they work. These concepts apply regardless of whether you're coding for Excel, Access, Word, PowerPoint, whatever. They apply to VBA. So hope you enjoy. I use the AI generator voice for this because he talks way more smoothly than I do. However, if you don't like it or if you do like it, leave a comment below if this was helpful. Thanks so much.
When you first begin learning VBA, regardless of application, there are 4 concepts you should be very familiar with: collections, events, properties, and finally, methods. Let's tackle the first concept because it's the easiest. Collections. A VBA collection is an object that is a grouping of other similar objects. Think of a folder on your computer's desktop. Within that folder may be 0, 1, or any number of other objects. The folder itself is an object, and everything within the folder is also an object. Here is what a collection entry might look like in the Microsoft Office model, which is online. Note there is an entry for worksheet, as well as worksheets. Do not confuse the two. A worksheet is a singular Excel worksheet object, while worksheets, with an S, is an object referring to the entire collection of worksheets. We also see this phenomenon when coding in VBA. In the upper left, we see Excel suggesting an object for a variable. Notice there are both worksheet, singular, and worksheets, plural options. It's the same in Access. In the bottom right picture, we see VBA suggesting both form, singular, as well as forms, which is a collection. Setting a variable to a collection is very simple. Here is some sample code. We declare WS as an object, while we keep the variable ITM undeclared, which means it's a variant. Then we set WS equal to the worksheets object of the active workbook. Now, we can loop through each object in the variable WS collection and print that object's name. Since we know the worksheets collection contains all worksheet objects, we know this code will list the names of all of our Excel worksheets. You may be wondering, but how do I get to an individual item and not the entire collection? I'm glad you asked. There are several ways to do this. The first way to get to an individual object, or member, of a collection is to use that member's index number. Collection index numbers start at 1 and will go as high as there are objects in the collection. Here we see a debug.print command. The command was issued against the first member, indicated by the 1 of the worksheets collection. In this particular case, VBA Lesson 1 was the name of the first object in the collection. You must be aware that indices may change in a collection, so you can't necessarily depend on index 1 always being this particular worksheet object. Another way to refer to an individual collection item is to refer to its name in quotes within a set of parentheses immediately after the collection object which holds it. Using this method, it doesn't matter what the object's index number is, no matter where it is in the collection. As long as you use the correct name, that particular object is returned. Yet a third way to refer to a singular object is to use a bang operator or an exclamation mark right after the collection name. If your object's name has spaces in it, you must wrap that name in square brackets. If the object's name does not contain spaces, you may simply type the name right after the bang operator. Here's how you would set a variable to an individual member of a collection. First, we declared WS as an object. Then, we set WS equal to index number 1 of the worksheets object. This means WS is now a singular worksheet object. When we debug.print the name of WS, we see the result. Note that while we use the index number method here, we could have just as easily used the other two methods we previously discussed, assuming we know the object's name. Now we'll do something slightly different. In the previous example, we referred directly to the worksheet's object. Here, we've gone one step further by creating a colW's variable. We set that variable to the worksheet's collection object. Now, when we set the WS variable, we can refer to the colWS and index 1. If you are constantly referring to both the collection as well as individual objects in code, this would be a cleaner way of doing so, setting a variable to the collection, then referring to that variable's name, instead of always typing out activeworkbook.worksheets. The second major concept to consider are events. Events are just that. When something happens to an object in VBA, we have the option to tell VBA to run code during certain events. Events are easy to research. Simply find the actual object in the Office object model, then look under the Events header for that object. In this example, we're viewing the Activate event for a worksheet object. Remember, we're looking at a singular worksheet object, not the worksheets with an S object. As you can see in the description, the Activate event is pretty straightforward. To actually use an event, we have to write code within the appropriate event block. In Excel, it's a bit tricky to find an event, because you must find it through the VBA interface, or directly write the procedure. In this example, we've attached a bit of code to the Activate event of the Sheet 1 worksheet. Whenever this sheet is activated, a small message box will appear. Note that this event applies to just a single object, worksheet Sheet 1. If we want to have code activate for either of our other two worksheets, we will need to view the code for those objects and then code a routine for their respective Activate events. In Access, it's much easier to code for an object's events because most of those events are listed in the object's property sheet within the Events tab. Here, we have selected a command button and we're viewing events for this button. To code something for, say, the onClick event, we would click the three dots and select Code Builder to jump straight into coding for that event. You must remember that coding for events can be tricky, especially in Access, because Access objects may have several events occur one after another. It's essential to read up on the order of certain events, as well as any caveats for that event, so that you have a clear understanding of when that event actually takes place. The next two concepts are properties and methods. These are a bit tricky because they can behave differently depending on circumstances. First, properties. Properties are usually a characteristic or a setting for an object, but not always. Here is an example entry for the name property of a worksheet object. We see it's pretty straightforward. The name property is a string and can either return the object's name or set it. And here's what some simple code looks like for that property. First, we have a variable WS as a worksheet. We then debug.print the name property of the WS object. On the next line, we set the name property to a different value. In this case, this is literally renaming the worksheet to Goat Channel. In Access, to see an object's properties, you can look at either the Format, Data, or other tabs within that object's property sheet. Note that while you can set the property here, using the Access interface, you can also set it just as easily in VBA code. Here's where things get tricky. Sometimes, referring to a property will actually return an object, instead of referring to a normal setting as you'd imagine. When you first experience this, it can be very non-intuitive, but it's really pretty simple once you know how it works. Look at this example from Excel. The columns property of worksheet actually returns a range object. So, for example, if you were to try to code something like worksheet.columns.fillColor equals 255, it would fail, because fillColor isn't a property of a range object. Here is some code that does work. First, we set our WS variable to a worksheet. Next, we set our cols variable equal to the columns property of WS, which, remember, returns a range object. Now note what we do next. We refer to the first column of the variable using the index number 1, and we print out the property address. It looks a bit confusing at first, but with practice, it becomes almost second nature. The final concept to tackle are methods, and like properties, they have a caveat. Usually, a method will perform an action for an object. Here's an example of the worksheet activate method. Whenever we call this method in code, it simply activates that worksheet. If you look at the code example, it's very simple. We follow the variable WS with a dot, and then the name of the method, in this case, activate. This would make whatever worksheet is located in index number 1 active. Something to keep in mind is that sometimes events, properties, and methods can have the same name, so it's essential to keep them straight. Here we see there is an activate method as well as an activate event for an Excel worksheet. The activate method is used in code to do something, to activate the worksheet. The activate event, on the other hand, lets you run code as that worksheet is activated. The caveat to methods is the same as that of properties. Occasionally, calling a method will not perform an action, but rather return an object. Here is an example of the worksheet pivot tables method. If you simply attempt to call this method in code, it will fail. That's because it doesn't perform an action. Instead, calling this method will return either a single pivot table object or a collection of them.